Okay, so we've been working through these look for steps, and the first thing we want to look for again is parentheses, which means we're going to distribute. Then we want to look for multiple things on the same side, which would be called combining like terms. Those are the first two things you should look for every problem. Now, it's possible that the problem that you're coming to doesn't have either one of those things that you have to do. Those are our level 1 problems. They don't have either one of those things. So when you get to a level 1 problem, you can skip over those and you go right to looking for the x's on both sides. And we're going to undo the smaller one. Undo the smaller one. And then what you're wanting to do is look for add or subtract next to the x, and you want to undo it. Okay? And then at the end, it's always division, but those are the steps kind of broken down a little bit easier for you. So this first problem, sorry, there's definitely a typo. Apologies for that. But this is what we did yesterday. So yesterday we dealt with this distributive property. So let's change that to an x and get started. There are parentheses in this problem, so I will worry about those. We're going to go 2 times x and 2 times 8. So 2 times x is 2x. 2 times 8 is 16. Bring down my 3x plus 24. Which x is smaller? I have an x on both sides, so which one is smaller? My 2x is smaller, so I'm going to subtract 2x from both sides. I end up with this 1x scenario again, so let's just put x. And now we're ready to get rid of this number that is being added to x. So I'll subtract 24. So I still have an x here. The x has not canceled itself out, so be careful with that, because you're going to kind of think that in the future. Even though there's still an x there, it just happens to be 1x. 16 minus 24 is a negative 8. And there's my answer. Okay, that's what we did yesterday. So don't think, oh, we're doing the same thing. Nope. If we go down to the next one, it looks suspiciously like the problem that we just did. So let's start it the same way, but it's going to take a twist right in the middle of the problem. So 2 times 1, 2. 2 times x, 2x. And over here I still have my 10 and my 2x. Okay, so it started the same way. I just did that distributive property, I multiplied. But now when I ask you the question, which x is smaller, which one's smaller, negative 2 or negative 2? They're the same. So when I do the opposite, okay, it says undo the smaller. That's what we're doing. We're undoing the smaller one. Well, since they're the same, when I undo my 2x, both of my x's cancel out. So what's left over here on the left? The 10. What's left over here on the right? 2. What does that mean? Sometimes there are special case problems. Yes, I do have answers sometimes. Sometimes I get an answer x equals -8. Sometimes the x disappears. So if the x cancels out on both sides, you have what's called a special case. The special case is either a no solution or it's an infinitely many solution. What does that even mean? Okay, well, a no solution means there are no values for x that will make this equation true. Not a single one. If I put x equals 1 into this equation, it's not going to be true. If you put -8 back up into the original equation here, that would be a true statement. What you get is awesome, perfect, true. It works out. Here, this is telling us that there is no possible answer that would work for this equation. So what does it look like? How do I know when I'm supposed to write a no solution? A no solution happens when your x's cancel out and you're left with something that's not true. So you're left with 10 equals 2, for example, or 7 equals -9. Okay? It's any statement that's not true. What do I mean by statement that's not true? Does 10 equal 2? If I handed you a $10 bill and you handed me back a $2 bill, is that equal? Is that even? Is that the same thing? No way. Give me my 10 bucks back. So that's not true. These are not equivalent. They are not the same thing. So that's not a true statement. So up here, when this happens, you have to write no solution. However, if you end up getting something that is true, 10 equals 10, for example, -7 equals -7. That means you have what's called infinitely many solutions. What does that mean? That means every number works for x. So if I distributed up here, we're going to do the second problem. I'll distribute. This problem also has lots of parts to it, so this is a good problem for us to do. We'll start with distribute because I see parentheses. 8 times x is 8x. 8 times 2 is 16. I just recopy that right-hand side. Then this problem has a combining like terms element to it as well, because what I have here is I have 2 x's on the same side, so I can put them together. So -7x plus 8x, that is a 1x. So I'm going to put those together. 1x and we get to a point here where I'm going to ask which one is smaller. Well, they're the same. I have a 1x here and I have a 1x here. So if I subtract that from both sides, they're going to cancel out. So if you're left with something like negative 16 is equal to negative 16, that is something that's true. 16 does equal 16. Negative 16 does equal negative 16. So what do I write? That is when I write that I have infinitely many solutions. Okay, so those are our two kind of practices for, or two special cases, for this level 3. So level 3 you do need to be able to do combining like terms, you do need to be able to do distributive property, and you need to be able to identify if a problem would be a no solution or an infinitely many solution problem.